The Earth's rotation is indispensable to its dynamic balance, influencing our diurnal cycle, climate, and even the shape of our planet. Though the notion of Earth abruptly ceasing its spin may seem akin to a science fiction narrative, probing this scenario offers significant insights into terrestrial processes. This exposition examines the physics, immediate environmental consequences, and the long-term impacts of such a catastrophic event. The Earth's rotation, approximately 1,670 km per hour at the equator, engenders centrifugal force that partially counteracts gravity. This force contributes to the planet's oblate spheroid shape, where it bulges at the equator and flattens at the poles. Should the Earth cease its rotation instantaneously, the kinetic energy would produce drastic effects on everything situated on the surface. If the Earth stopped suddenly, the atmosphere, oceans, and surface entities would persist in their current motion at rotational velocities. The cessation would lead to colossal winds, traveling at 1,670 km per hour, capable of annihilating structures and ecosystems indiscriminately. Similarly, the momentum retention in the oceans would trigger significant tsunamis, inundating continents and altering coastlines. In the absence of centrifugal force, equatorial water would migrate towards the poles under the influence of gravity. This would lead to vast arid equatorial landmasses and polar inundation. Concurrently, acute stress on the planetary crust would precipitate widespread seismic and volcanic activities. The elimination of centrifugal force would also imply an increase in equatorial gravity. This would render objects heavier, alongside a gradual morphological transformation towards a spherical shape. An immediate effect would be an alteration in the diurnal cycle. Days and nights would elongate to the period of a year. Prolonged exposure of half the planet to the sun would lead to extreme heating while the other half would freeze in continuous darkness. In long-term environmental ramifications, the Earth's magnetic field, generated through its rotational dynamics, would weaken or vanish. This would expose the planet to solar radiation. Without the Coriolis effect, weather systems would lapse into disarray, leading to erratic climate phenomena and ecological collapse. Hypothetical circumstances enabling Earth's rotational cessation include a sudden halt or gradual deceleration. A sudden halt could be inspired by an immense external force, or a gradual deceleration, which is realistically inhibited by tidal interactions with the Moon. Survival strategies could involve advanced preparations, like underground shelters, to evade severe weather conditions. Energy shields could counteract magnetic field loss, and artificial measures could sustain suitable living conditions. In conclusion, Earth's cessation of rotation would enact catastrophic transformations across its surface, accentuating the fragility of the forces that sustain terrestrial life. While hypothetical, this contemplation encourages deeper respect and conservation of Earth's stability against natural and anthropogenic alterations.